Guys, making a video that's a little not off topic because I don't have too much of a cohesive one, but just about getting input for competitive programming in Rust. I'll try to trim the fat and not rant too much. So C++ is currently the king of competitive programming, but it's not very loved, at least kind of in the terminally online programmer Twitter sphere, but there's some good reasons for that. There's a lot of feature creep. The language is really complicated. The language spec would take like 100 hours or more to read. The build system's not great. You have CMake, Make, Mason, Ninja. You just have a lot of variety, and installing dependencies is really difficult. You usually have to clone it, build it locally, and then reference the local build that you have. And you do have a lot of foot guns. You can have a lot of memory leaks, memory issues. And Rust is kind of the new kid on the block. It's not as new as it used to be. It's very loved, possibly too much. I feel like everyone's trying to rewrite working software. I think that's not the best look for a language. Doesn't make people as enthusiastic about it. Instead of having foot guns, you're kind of stepping on feet, if that makes sense. But it's got a great build system and package manager. Cargo makes starting new projects, getting dependencies really easy, and I think that contributed a lot to the expansion of the language. And it is also really complicated, so people kind of lump Rust with C++ and maybe C with Zig, but at least with Rust I feel like every added complexity has a purpose. It seems to make sense. So handling input with C++ for competitive programming, it's extremely simple, it's really easy. So this if-and-def is a simple macro, basically saying if you don't pass this online judge flag, then treat input.txt as standard in and output.txt as standard out. So this makes it really easy to kind of test your submissions locally. You have an input file and output file. You don't have to manually type the input data at the command line through standard in, which for some problems would be like borderline impossible. You've got 30, 40 lines of input. You're trying to type it correctly. You're trying to make sure that you're not making errors. It's just not really that feasible. So you can see here, once you've set this, then you can just declare an integer. You can read it with the C++ cin, or you can use the C style scanf, and that's pretty much all you have to do. Now, Rust, it's a little bit more difficult. So you have to make sure that you have all your types aligning, and you have to defeat the borrow checker. So it's pretty frustrating at first, especially when you're starting out with Rust, but once it all clicks, I feel like the solutions are a lot more elegant, and you kind of understand what's happening a little bit more. So you can't have simple macros. Again, manually typing input, not really feasible. And if you set the file input, you'll have to change your code when you submit to an online judge. Maybe that'll cause some errors, some things you're not expecting. And for output, I think println's perfectly fine, especially when you're starting with competitive programming. I read on some forums, people are like, oh, you can't use println, you have to use this or do this, but just going to keep it simple and use println. So this is a really complicated example, but from advent of code, that include string works great. It basically embeds the text file in your binary, and you can just iterate over it with lines. You can do this function or method chaining style. So here I'm just transforming the line, splitting for colons, semicolons, commas, spaces, etc. But the important part of this is this method collect. So what collect does is it takes basically this split of strings, or it could be any iterable, and what happens is this collect turns it into whatever type the variable that it's being assigned to expects. So essentially this vec string is saying that whatever I have that's being iterated on, this split here, when I collect it, I want it transformed into this type. And if you can't transform the type, you'll get an error. The LSP will show you. But for the most part, collect is very flexible, and you can do a lot of really neat stuff with it. And the thing that I like about it is it's the type system is so precise that once it clicks into place, it's kind of like playing Tetris. It's a little frustrating at first, but when it works, it's nice. And sorry for using the mouse. This presenter plugin, if I hit L, it goes to the end, messes up the whole presentation. So handling standard input. So this is a simple function to just take in some string from standard input. So here I have a buffer. I have to tell the compiler that it's mutable, meaning that its value can change. I get the standard in from IO, and then I read one line. I unwrap it because it can fail. So that unwrap basically opens up the error type and gives you the value. And I read it into a reference of buffer, a mutable reference because I'm changing it, and then I can print it out. So there's a great starter template on rustp.org, and they have something for take int, take vector, take string, and toString. And this makes everything really easy. And you can see here with collect, for this, they're using explicit typing. This is basically saying collect it into a string. So a string is kind of like an array, kind of like a vector. In C, it's just an array of characters, an array of chars. So that's why we can pass this into the collect function as a type. But here we can see we can't read from files. So when I was starting out, I really appreciated this and I built on it a little bit. But the main thing I wanted was to be able to switch between reading from files and reading from standard in. So the first thing that I did is I just wrapped it in a module to keep everything pretty clean. So you can either do this above your main function, which is what I did for submissions I submitted, just because you can't have multiple files. So it's pretty short. You just put it right on top of your main, and then you can use this RCP, take in, etc. So the first step was just making a module. That way, if you don't use something, you don't get an error that you haven't unused. You don't have to add that unused macro. And then the second step is I decided to make it polymorphic on the type that you want to get back. So here's just a really simple example with read. So here, what this is doing is this is some of the kind of type complexity, but again, you can see the reason behind it. So I'm saying that this T type has to implement a trait, and you can think of a trait kind of like an interface. It has to have the from string trait, and that's because we're reading in essentially strings from standard input or characters. So I have this type T that implements this trait from string, and then read returns that back out. And basically what I do is I read this, I trim it, I parse it, and then this .ok is kind of like, all right, did this work? And if it didn't, I expect with failed to parse. And these just kind of help when something's going wrong, you can just unwrap. But if you do that without a message, it can be a little bit harder to find it. So here I have a message and a float. I read those in, and then I print them out. So that just gives you a little bit more flexibility. If you wanted to use a string, a number, you didn't want to have to just use integers. Maybe you need a long, you need an F64, etc. Just makes that a little bit easier. So the next thing that I wanted to add was file input. So here, if I use cargo to run with the file passed in, -- file, instead what I have is I have this init reader that returns out, again, some boxed type that implements buff read. So what I do here is if this flag's passed in, I say, okay, I'm going to box a buff reader of an open file. So again, here I'm opening a file. If it doesn't work, it tells me. Otherwise, I box standard in. So you do have to use a box type here, which is kind of like a reference. It's almost like putting something on the heap. This gives you a little bit more flexibility. You'll see it a lot with more advanced Rust. But it essentially allows me to have two different types or two different objects stored in the same container object, which would be this box here. And I know people use containers with arrays and vectors, so I'm not trying to muddle the definitions there. But what this allows is it allows you to set your reader as being a file or standard input. The only downside is you have to pass a reader around as you read input, but it's not the biggest problem. So you can see the final template putting everything together. We have a module RCP for Rust competitive programming. I have read, which is polymorphic on T, as long as T implements from string. And then for everything that I do, I have to pass in this reader, which is a mute impl buff read. So basically what that means is this is a mutable reference to something that implements the buff read trait, which we can see is either a file that we open or standard input. Oh, can't use the normal keybinds in the presenter, sorry for that. So here we have read vector. So this allows me to read in a vector of any type, essentially. So I can get out a vec of t. So you can see here the t is exactly the same. The only difference is that the return type isn't just t, it's that vec t. Oh, again, these key bindings are killing me a little bit. So got to just remember its presenter here. So string.new, it reads it, it splits on all the white space, it tries to parse everything. So this parse is like collect. It just looks at what the type that you're expecting is and tries to parse it to that. And if it fails, it'll tell us failed to parse. This isn't read line, this is read vector. I think I changed that in the code that I use. And then one other important feature is this throwing away of empty lines. So when I was testing this out, I was getting everything working locally, but then the online judge was rejecting it with an runtime error. And I saw that, there's new lines after every test case. So what this does is this just throws away a line. So if you have empty lines and you know where they're going to be, most problems will tell you after every test a new line, you can just throw it away. Then we have our init reader, and we're pretty much off to the races. Whoop. Sorry for using the simple bindings. I just don't know what's going to go crazy in this presenter plugin. So here's how you'd use the template. You either have your module above your main, or you import it from a different file. You initialize your reader, and then you pass it around as a mutable reference. And remember, whatever reader is, standard input or a file, it implements that buff read trait, meaning that we can use either one without really worrying about it. So the type of this is either boxed, I'm not sure if it's called IO or boxed file reader, but it's just a box type that implements that. So this SHPATH problem, I got most of the solution from this book. It's a really good competitive programming book in Rust, but it omits certain things like getting input and stuff like that. But it is a great book. Definitely recommend checking it out. Let me see. Yeah, SHPATH, shortest path. So this is just a Dijkstra algorithm implementation. You can see what the input looks like here. So we get the number of test cases, the number of cities, the name, the number of neighbors, then we get the index of the city that it's neighboring and the cost. And we get the number of paths to find, then we get the source city to the desired destination city, and then here's the empty line that was tripping me up a little bit. So here's an example of what some input would look like. One test case, 4 cities, city 1, 2 neighbors, city 3, 3 neighbors, the cost, etc., etc. We want to find the minimum cost from this city to this city and this city to this city. And then we output like so there. So if I go to, whoa, I'm still in presenter, interesting. I can't quit out of it. One sec. All right, this is definitely fighting me a little bit. Let me see if there's a key binding to quit this. Nope. All right, just gonna close and reopen. So if I go back here, Rust SHPATH. So you can see here, because I'm submitting it to an online judge, I just include the module. And we're going to need reverse, and we're going to need binary heap and hash map. So the first thing I did here is just looking at the problem details. We know that there's going to be no distance greater than this. We know there's going to be no size greater than this. So what I do here is I make a reader. I make an adjacency matrix. So this is a vector of tuples. Essentially, this is just a tuple of u size and I size. And I use the vec macro to create it. and I set its size to max. So essentially there's not going to be more than this many cities that we have to track. I think that's 10,005. Then I init a hash map of string to usize, so basically city name to index. And then here I just take in the number of test cases. So while my test case is greater than 0, I iterate through this loop. So the first thing is I decrease the test cases, don't want to forget about that, and I reset all of the data types or the data structures that I'm using. So I reset the adjacency matrix for each test, and I clear the hash map. And the reason that I instantiate these up here, especially the adjacency matrix, is because I don't want to keep creating it over and over again for every test case. So then I take the number of cities, again, RCP read, I want to usize out, that can parse. And then for every city, basically what I do is I read the name. You can see here, just set the type to string, read with the reader, and then I insert the city and the index into the map. And then for this, P is essentially the neighbor of the city, right? So I read in the number of neighbors that it has. Neighbor cost, vector of I size, read vec makes it pretty simple. For the neighbor cost, I take in the kind of the first element, and I have to convert it to a usize, and this is mainly because I'm going to be using it as a subscript to a vector. So subscript is something like this. It has to be a usize. You see here, this 0 gets typecast as a usize, whereas if I were to just write let x equal 10, it would probably cast it as an int. Then the cost is the second element in that tuple. And the reason I'm using a vector and not a tuple here is it's just a little bit more simple. I know that I'm going to be getting 2 values out, so I can just kind of hard code 0 and 1. And then I push this as a tuple instead of a vector into the adjacency matrix for city I. So R, number of paths to find. For every path, I read in the cities as a vector, again, just using a vector to make it easy. And then I take in a reference to a string for each city. So this would be the source. This would be the destination. And you can see here, I get the source from the map. I get the destination from the map. And then here, I want to find the distance. So I create this distance matrix with the size that I set to inf, and then with the max as the max distance. And then I create a vector of processed city. So basically a city I've seen or haven't seen. And here for the Dijkstra algorithm, we want to use a binary heap, but we want to sort by min distance. So it would be a priority queue, essentially. So to get that functionality, we just have to use this reverse function. So it basically reverses the order in this binary heap, allowing us to use it as I think a min heap is the correct term, or a priority queue. So we set the distance from the source to be 0, then we push it in, and then while we have some cities to visit, we take out the neighbor, and then we process it, continue, and then we set process to true. If we've already seen it, we just continue. Then we determine the min cost to get to this city, and you can see that this right here comes from so basically from the city before, what's the minimum cost to get to this next city, A. Sorry for not explaining that great. And then I compute the distance to the city, and I push it in. And then the last part is you just print out the answer and consume the new line. So here, if I look at the input, you can see it's the same test input. We have this blank line right here. I think the answer I want to get out is 2, 3. So if I do cargo run with nothing, it's going to start expecting input. It's going to start freaking out. And you can see why typing it manually just isn't an option. But if I run it with file, I get 3232. Oh, the reason here is because I, just to make sure new lines were working, I added the test case twice. You can see here it's 2. So for this, if I just set it to 1, yeah, should work just as well. So a little bit long at the end. Sorry about that. Didn't prepare to explain that algorithm. Probably didn't do the best job, but the main idea here is to just show this template for taking an input. It should get you most of the way for, I'd say, like 99% of problems. There might be some edge cases it doesn't cover. It might be inefficient to store things as strings, but it works well. It ran a little bit faster with a little bit more memory usage than the C++ submission I had. So, you know, you're not losing that much speed. You're gaining a little bit. The only memory use thing was the, where is it? Sorry. The distance and processed. For some reason, I had to define them inside the loop. I couldn't reset them outside. Just a skill issue, me not being the best with Rust, but that's why I love these competitive programming problems. I'm never going to be super great at it, but in terms of exploring a new language, doing some problems, learning some algorithms, it's a great way to just have fun if you enjoy coding. So thank you guys. Have a good one.